Yes, I just want to apologise here first up and just say that appears that the title of the workshop was not actually well designed, but actually I want to talk to you more around well integrity today, and that's more around, we've heard this morning quite a bit, it's around the investment of drilling wells and the investment that operators and the performance they expect out of it. So how can we go about protecting these wells, and how do we go about ensuring that your investment is there for the long term? Some of the things around MB Century, what we've done over the years, and that's largely driven from our years of experience and dedicating ourselves to the geothermal industry, and how we've gone about actually developing specialized tools to actually interpret the data, interpret your well casing, to make sure that we are harnessing the resource in a safe manner. So we are the only company, geothermal company, that's actually dedicated to actually designing and building and actually running our own tools to really drive that integrity and make sure that we can secure your asset going forward. Some of our tools within our suite, I just want to highlight a couple here today, is our PTS tool. We've taken that and really specifically designed our spinner to actually give you the best data available. We are able to run this in a static mode, but also we're able to run it while your well is flowing. The high temperature casing tool is...
Sorry.
No problem, man.
Catch you later. Sorry to interrupt.
And what we want to do with the high temperature casing tools is actually look at your integrity of your well. The XY caliper, that's really around when you are drilling to actually work out, you know, what is the size of your bore to the size of your casing, and we're using that nowadays to actually calculate the volumes of cement that you're actually pumping into your well. So that's been used quite a lot. And then downhole sampling, radial bore logging, that's become really important for us, right? To really understand what is that cement bond between the casing and the cement, to make sure that you haven't got water trap behind it and that, you know, you are getting that appropriate bond. So RBL logs has become a big part of the way that we're running various tools while drilling.
Okay, 513.
Just noting as well today, high temperature is becoming an issue, right? The tools, and this is where I think MB Century has really developed over the last few years, is actually being able to drive that maximum temperatures, and we're able to run temperatures well over 300, but also for extended number of time. Our spinner, like I said, really gives us some deep, rich data. The HTCC casing one, so I'll show you a little video how that works shortly, but it's using electromagnetics down in the well source. But as you know, temperature and electronics don't go well together, right? So we've developed special flasks that we're able to actually retard that heat that could get into the electronics, but making sure that we have sufficient time to log that data as well. And the nice thing about us at the moment, we're able to run both these on a slick line and an E-line. So that E-line gives you real-time data. You're able to interpret it, but it's able to run up and then back down in case we find something interesting for you.
Can I ask a quick question?
Sure.
Some of the challenges I've seen for that is the whole system needs to a certain extent be able to handle the temperature.
That is correct.
I guess you have also not only being able to handle the tool itself with that blasting it, but also the cable.
But also the wire line, the whole, and the connection as well. The connections become really important so we don't lose their data. What we also run as well is we run it in memory in the same time. So in case we do lose connection, we don't lose the data. So we're able to run both. Probably the latest tool that we've brought to market recently is the HTCC Extreme, and that's become really important for us because it's able to read 5 casings at once. So this has become really important in that top section. We heard this morning about how important it is not to contaminate your shallow aquifer, and what we're seeing is there is potential corrosion happening in those 5 casings. Historically, we've only been able to look at the one casing with the immediate casing next to the one that you're logging. But now with the Extreme tool, we're able to look 5 casings deep, right? Which we are then able to determine where is that leakage coming. Because quite often we find operators approaching us going, hey, we've got a leak around our annulus up at the surface. They're not actually sure which casing or which string is leaking. So with the Extreme tool, we're able to then identify which casing is potentially causing us issues on the wells. But once again, we've taken that tool, we're able to provide it with some really cool technology that we have in-house and actually high temperature this tool. Probably the crown in our jewel is, sure, go for it.
Just a question regarding the tools that can read 5 casing. Is it quantity or quality reading? How many quantity, how many quality?
When you say quantity,
I mean, which can you read the casing for reading for each one by percentage, or some of them you cannot identify exactly for the for example for the most outer casing?
Yeah.
You cannot give an exact value. Just quality. Yes.
No, we're able to exactly point you which casing and which location. It's not an average number.
Oh, for the 5.
Yeah. Yeah.
Oh, for each one separately.
For each one separately, yeah.
Okay, thank you.
And then probably the crown in our jewel is probably our multi-finger tool. This tool has been really developed over the last, I would say, 5 years. And I suppose for us, we've had to collaborate with the university and the motor manufacturer that actually works with the Mars rover to apply the same motor technology that's on the Mars rover to what we've done with the multi-finger tool, and use that same motor because it's a hot, corrosive environment, which is exactly what's sitting at the bottom of your hole, right? So working with them and actually deploying that technology on that downhole tool so that we are able to open up all 60 fingers in that hot environment, but also being able to retract them as well.
Just
Go for it.
comment if I may, that just from a well integrity standpoint, a lot of clients forget that it's a really good idea to do a baseline as soon as you've completed the well. It's often the case, and I don't know whether it's your experience, that the clients only call you in a lot later in a project where corrosion's already occurred. And when we're doing well integrity training in oil and gas, keep reminding the clients that you've got to really have a baseline so you understand how things have changed with time. So anyway, just a comment.
Yeah, no, thanks for that. I suppose for us, when we do completion testing on our wells, one of the ones we do want to do is a full baseline test of our HDCC. Understand the casing, understand what your condition of your well is right up front. In New Zealand, there's a requirement to actually log all your wells with an HDCC. So it's your injection wells, you are required to log it every 5 years. Your production wells, you have to log them every 2 years. So that's both from an insurance and a compliance perspective, where New Zealand have moved to actually regulating that to understand the condition of these wells.
One quiet day, natural forces below a geothermal energy field at the bottom of the world caused a destructive event. Without warning, high-pressure steam forced its way to the outside of a well's casing and exploded to the surface. An immense crater running 70 meters long had been blown into existence, and a functioning well, its plant, and a valuable resource was destroyed. Around the world, billions of dollars are invested in harnessing the rich resources available beneath our feet. However, there is an ever-present potential for these events to lay waste to that investment. What starts as a minor leak can go on to severely damage the business asset and its reputation with it. Well maintenance is often a major challenge. It's not easy to run a safety check on something you can't access or see. But times are changing. Regulations demand more accountability, and a very real public expectation exists for all companies to act responsibly as part of their social license to operate. This all points in one direction: down. It's time to expand our thinking to below the ground. Fortunately, through years of development and real-world testing, MB Sentry has developed the industry-leading high-temperature casing condition diagnostic system, which can be run in 3 modes. The EM mode uses electromagnetic technology to measure variations in the thickness of a well's casing. From that data, we can diagnose the presence of pits and corrosion on the casing's internal and external walls. In MF mode, the tool uses high-precision displacement transducers deployed into 60 mechanical fingers to gather and analyze even more detailed information from the casing's internal wall. Data is presented via software at the surface, and with this intelligence, we can diagnose with accuracy the presence of pits, levels of corrosion, and also what mineral scaling exists. Perhaps most significantly, this system is able to run both EM and MF modes simultaneously and at extreme temperatures for extended periods of time. A key benefit of this is, unlike other tools, MB Sentry's HTCC diagnostic system can run without the well needing to be cooled or quenched, therefore avoiding thermal stressing of the casing. Now, for the first time, a detailed assessment, both internal and external, can be achieved with a high degree of accuracy in one efficient run. Data is collected in both EM and MF modes. From this data, reports are generated including 3D visualizations for easy interpretation. With this world-leading technology and expert analysis, well owners can be armed with a risk profile and the knowledge they need to make informed decisions and repairs. So what does this all mean? Firstly, improved protection of hugely valuable assets, reduced risk of a blowout and the uncertainty that comes with such a major event, improved environmental and workplace safety, avoidance of costly repairs through early detection, an increased lifespan of the well as peace of mind for operators and stakeholders. Finally, a realistic path exists for well owners to protect all their assets, including their primary asset, the geothermal field on which they operate. With MB Sentry's HTCC diagnostic system, these resources can now be managed and protected for the benefit of everyone.
Right, so I suppose the nice thing about the multi-finger tool, right, it's not just using EM, so you're not just looking at the corrosion. The thing with us, we're able to quantify is whether you've got scaling. And it's something that we haven't spoken a lot during this conference, is actually the scaling that you get while you're producing. And this might come in a way of silica, calcite, and actually causing quite a lot of issues for producers as you drive fluid up, as you're dropping pressure or you potentially dropping temperature, right? You're causing those solubles to actually precipitate out of the fluid. The thing that the 60-finger tool is helping is actually to determine what scaling you're getting, but also at what location, right? So I think that's been the big driver behind the multi-finger tool, is actually not just only corrosion, but also let's understand the scaling that you're getting in your wells. All right, I think that's me. Thank you very much. You got any questions?
Yeah, Richard.
Yep.
Through this data set that you've gathered over the last couple of years, this data set, has it changed your casing design or your casing material specs?
Yeah, so we have changed particularly casing materials, and really trying to match that with the type of reservoir that we're getting. So we are seeing some reservoirs, we're seeing quite a lot more acidity, and that's largely driven from magmatic fluid, especially in the deeper wells where you haven't had that sufficient resident time for the fluid to be sitting in the rock to neutralize that acid, and you're getting very young fluid, and it's in these reservoirs that you're finding that young fluid that has got that magmatic fluids and probably the acidity sitting in it.
Okay.
So both from the types of connections that we're using. So over the last few years, we are seeing a slight change in the connections that operators are using for their casings.
Cool.
I guess a related question, what about cement?
Yeah, cement has tend to be, I would say, very much on the client side. In New Zealand, we have a couple of operators that are really driving their own cement mix. And once again, they've taken those lessons because of the reservoir and the type of reservoir that they are sitting with. So we are seeing different operators with different cement mixes.
Interesting. But I guess typically still Portland with some silica or...
Yeah, there is the traditional mix, but they are tending to blend it a few more with a few more agents.
Any questions?
Just a quick comment as the place is suited to. Yeah.
Thank you very much.
So these tools have been used in the field and tested in actual wells.
Yes, they have been. Yeah. So they've been used regularly by the clients.
Oh, okay. So mainly in New Zealand, or you deploy it worldwide?
So probably for us, just the PTS tools, we do sell them as a whole. The HTCC tools, we run them both in New Zealand, we've run them in Indonesia, and we've run them in the Philippines as well.
Thank you.
Right. I think that'll conclude the workshops, and I think we're off to a field trip at the moment, which will be very exciting.
Yes. Okay, let's thank Greg for his presentation.